Thank you. Thanks for the introduction, Patrick. I know it's a little bit after lunch, and we're running a little late, so we'll get started. So what I wanted to talk about today was really the object recognition feature in Vuforia that we introduced a few months ago. And it was all around an opportunity to bring toys to life, right? So I want to talk first about the opportunity with toys itself and what people have done with Vuforia and toys today, and what kinds of experiences you can build going forward. And then I'll have David come up on stage here and show you how to use the object recognition feature in Vuforia to build those kinds of experiences. You know, one thing you'll see throughout this is, for those of you who are familiar with Vuforia, the programming model, the developer workflows, those are all pretty much the same thing that you've used to so far if you've worked with Vuforia. So it's designed to be simple, it's designed to be consistent. And David will walk you guys through it. But first, for those of you who are not familiar with Vuforia, by the way, how many of you have not heard of Vuforia? Okay, okay, wow, okay, that's good. Lots of familiarity here, so I can go through some of my introductory slides a little faster. So Vuforia is a mobile vision platform. It's a when we talk about Vuforia, we talk about it as a platform that enables applications to see things, right? So you and I, we have a sense of sight, we can see things, we can recognize there are people in the room, there are objects, there's a floor, there's surfaces. We want to bring the same intelligence, awareness, and sense of sight to applications on mobile devices. So it's a software, developer-facing software platform that we made available now for about 4.5 years in commercial forms, and it has really grown in that time. What it does is it takes very sophisticated computer vision technology and makes it very simple for any app developer to build these kinds of interactive AR applications. We're not talking about someone who's just skilled in computer vision or has an extensive background, but the idea is to expand it to any app developer who just quickly wants to add this kind of functionality to their applications. So just a very quick overview of Vuforia. Like I said, the API itself is really simple. All it tells you is, what am I seeing in the field of view and where is it? And it tells you that 30 times a second, so you know exactly where to place content based on that information. So we can recognize a few things. We can see a few things. There's images. These are natural feature images. Generally we talk about it as any image with a little bit of pattern and detail in it that works. And then objects, and this is really the feature that we're going to focus on in this presentation later. And this is rigid 3D objects, not soft, deformable objects, and not with too many articulating limbs either. And then we also have text. This is English word-based recognition. And then meshes. And meshes really is our smart terrain functionality. And what smart terrain does is it gives your applications the intelligence and awareness of an environment. So it helps you build a 3D geometric map of a table surface and objects on it, which we call props. And from a developer perspective, you're really not concerned about whether it's mapping correctly or if it's SLAM or what. All you're getting is a surface that tells you this is the table, and then meshes for each of the objects on the table. So it's really designed to be very simple, so you can build apps where your car collides into a coffee cup on a table or falls off the edge of the table. So it's that kind of bringing real-world physics to the immediate environment. We have SDKs available for Android and iOS, and depending on whether you want to program in Java, C++, Objective-C, or the cross-platform game engine Unity, we have interfaces for all of those. So it's really simple to use and get started. But what I'm really excited about is the amount of adoption that this platform has had in the last few years. It's just phenomenal. There are over 150,000 developers. The growth continues. It's very, very strong. And there are more than 15,000 apps that have been built for Android and iOS. And these apps have been installed more than 175 million times, right? So what that tells you is that this is not just like early adopter or sort of a niche developer thing, but it's actually being used by end users all over the world. I think of roughly about half our developer base is Europe and North America, but the rest of it is just spread out across Japan, China, Korea, India, really, really global phenomenon. That's how I think about it. Okay, so with that quick introduction to Vuforia, let's just talk about toys and digital play. So digital play is not new, right? It's been around for a long time in different forms. We started, the video games market has been around for 40 years, I think. A lot of us grew up playing games. So, you know, we're more comfortable letting our kids play with that. It's many parents with young kids. All of us grew up with this kind of digital play. Now, of course, it's morphed over a period of time. It started with these toys with some with digital content on it, and then the feature phone, and remember Java and J2ME and Brew and all those kinds of phones. And now it's all about mobile screens like iPads, tablets, and phones. So it's real. There are two trends, right? One is you're moving towards screens that are more standardized, like phones and tablets. And then the other trend is like the kids keep getting younger and younger when they pick up these digital toys. Like my daughter is about 15 months old now, and she will not have dinner until I show her something on a screen. Right? So and whereas my son was 4 years old, we started him off when he was 2 years. We got him latched onto that. So you can see, I can see that personally as a trend where the kids are getting younger and younger. I don't know if that's good or bad, but it is happening. Basically, digital play is going to be a much bigger part of children's playtime and their lives, much more than it was for us. So there was a study that Common Sense Media performed for kids under the age of 8, and they did it once in 2011 and then 2013, and the results are pretty obvious. I mean, you can see it from this graph here. The amount of time spent on toys and even traditional digital media has been going down, but what you see on mobile phones and tablets, it's up 10 minutes just in a couple of years. And I'm sure if you did this study today, that number is much higher. So I think, you know, here's a quote from Melissa and Doug. Do you guys know the toys, Melissa and Doug? They make these nice wooden toys. I really love them. I buy them for my kids. But this quote sort of tells you the state of the industry here. You know, we're waging war. That's how they describe it, right? And we're fighting age compression, and that's technology, and it's happening, and they really have to adapt to it. And I think there's some really nice things with AR because it's all about physical objects, and AR can really bridge these two worlds. That makes it exciting for us as you know, technologists, is being able to bridge these two. So I have the digital play, and I also have physical play, and I think that's where the real opportunity is. So toys are going digital. This is, you know, again, I'm not saying anything new or here. This is just a trend that's happening. Skylanders, Disney Infinity, all happening. Very successful toys. There are many Vuforia-powered toys today, even without our object recognition feature. And this is what caught us a little bit and got our attention. And then you know, we started looking into this closer to look at this. What exactly are developers doing with this? So these are all existing toys that have been built over the last 3 or 4 years. So there's Nerf, the Nerf gun. It has an app that actually has, and you know, so with its line of blasters, you can get different environments and different experiences. It's a little marker that you put right on top of the Nerf gun. Very, very interesting. Then there's the Power Rangers app that comes with a key. So it unlocks a special power, right? So you need the physical toy, but it unlocks something new for you in the app. Here's another one. This is the world map. So you learn all about the map, and then you point at specific portions of the map, and then you see famous landmarks, and again, just augmenting that whole play experience, if you will. Here's another one, Tech Deck. Tech Deck are those small skateboards, the finger skateboards, and again, it's for unlocking that specific skateboard inside a digital game, right? So there's this trend about unlocking, which you'll see more. This is just again, this is another one that unlocks toys. So there's different kinds of digital play. The unlock one is, you saw a lot of examples of that in the previous slide. I think that's something that's fairly easy to do with Vuforia image targets and all the features that we had before. So that was, you're not actually, you buy the toy, you point at it, it recognizes it, and it unlocks some digital content for you. That can be a special power, it can be a special feature, or it could be that specific car model that you bought that lets you perhaps race that specific model in a different game. But there's it's an interesting idea where you're getting digital content, but I don't know how much you actually play with the physical toy. But it's the beginnings of a play pattern, and that actually is very, very popular. Then there's virtual toys. So this is all about, you use Vuforia, you control a virtual toy in a real world, right? So this is just 3D graphics, but it's a toy in your living room that you can drive around. Dino Mundi is a very immersive AR game. It's actually from, it comes from this company called Toystalk in Brazil. And what it does is there are a bunch of dinosaurs. It was actually built with the object recognition feature. You augment the dinosaur, and then it can interact with the physical, with other physical dinosaurs out there. So you recognize one, it puts an augmentation on it, and then you bring another dinosaur in, and there's something that happens. So you see the beginnings of rich, immersive gameplay, where you can put different physical toys together, and you have a digital experience on top of that. So you went from unlock to somewhat more immersive play. And then the Hot Wheels app, again, this is more like, I think about it as movie magic. So if you see that picture there, there's an iPad holder there. So Hot Wheels actually put plastic in there to put that iPad, right? This is how important digital play is to the whole physical toy world. And what that does is, as the cars are racing in that racetrack, as you'll see some augmentations, like you'll suddenly see a shark come out and grab one of those cars, or you'll see some dinosaurs augmented out there. So you can then record, you can take pictures, you can record short clips, and then you can share it with your friends, right? So that's the movie magic piece of it, where you're recording these experiences and then sharing this. This could just spawn a whole genre of toys and experiences out there. So what are customers saying, about, when we talk to developers and toy companies, just trying to understand what can be improved about current physical to digital play experiences. So here's what they say. So, we don't want to use any codes. It's just the cost and time of putting things on something, and it's just another step in their workflow. They want to try and avoid using these codes. Kids tend to lose the packaging. So putting things on, so you saw the early Vuforia experiences were all based on the product packaging itself. Right? So that works, but how often do you have packaging? So that's why they were unlocks. You unlock it once, and then you don't need the packaging itself. So this is a real problem. I mean, we throw away the packaging, right? It goes in the recycle bin. We want kids to play with the toys. The digital experience is important, but the physical experience is also important, right? So this is the key. You want to have a balance of both, because at the end of the day, even I'm very concerned that my kids are just on the screen all the time. So we want them to spend time with toys, and we don't want to force it on them. We want them to actually like playing with it. I think there's some skills that they build, and there's an experience that comes with it that's I think is really really valuable. And then it's of course it's too expensive to put electronics in toys, so they don't want to put any kind of sophisticated boards or chips or anything out there. It's just keep the whole keep the cost low. We can't change the toy. Many of these are iconic designs, right? You can't go and change Barbie, or you can't change Hot Wheels. You want to work with what you have. As much as you want to create new toy lines, it's easier to add experiences to existing toy lines. They're successful. These are brands. So there's only so much you can modify the toys before they're unrecognizable, or they're not, it's really not part of the brand itself. So we took all this feedback, and we tried to put it in our object recognition feature. So what it does is it enables the recognition and tracking of toys. So you can do things like this. You can take a car, and you can customize it with digital content. So this is so the way this would work is that you have a toy company that would actually build a physical toy, and then they'd build a companion app and put all this content in it, and the companion app would have the technology to recognize this car. So when you buy the product in store, maybe there's a link there that says go download the app and customize it and enjoy it, and that's kind of the model here. And the key here is that the digital content is applied directly on the physical object. So you look at it, you can see content on it, you can turn the car around, and you can really experience and customize it as if you are designing this car. So let me show you a quick video of what this could be like. This is actually a toy that Qualcomm produced, so this is not a real toy that you can go out and buy. Although I think it's pretty cool. So with object recognition, right, so these are really the 4 things that you need. You want the recognition to be fast. If you're trying to scan an object, it has to happen immediately. You can't expect a kid to hold his iPad there or tablet steady for a few seconds. It's got to happen really fast. It's almost like, for us, the bar is it's got to be almost as good as how we recognize images. Right? That's really what we want it to be. These experiences have to be registered experiences because you want the toy to come to life, right? You're putting a machine gun on top of that 3D object. When you move the car around, the machine gun shouldn't be flopping around wildly. It's got to stay where you wanted it to stay. It's got to be, when we talk robust to motion, so you're not going to have that toy sitting in one place. The instinctive thing that I see children doing is like pick up the car and they move it around and they want to see the gun and make those, the role play starts almost immediately. It's really magical actually when you see kids doing this. And then we don't have lab environments where these kids play. They play in their rooms, right? It has to work with the clutter and real world environments that are our houses and our children's rooms. So here's some examples of toys that actually work. Action figures, these vehicles, sort of playset prototype buildings, all these are good. They're rigid. They don't have articulating limbs. They're not deformable like squishy soft toys that just change shape. Those work really well. Of course, a solid blue color or yellow color car is not going to work. It needs some amount of detail. But we have the tools to show you what works and what doesn't work really well. I do want to say, I've focused a lot about toys because I think it's a good opportunity here. But the object recognition technology itself was designed to work with just rigid 3D objects. You can use it for a broader set of objects. People have used it for appliances at home, some even going as far as using it in enterprise for machinery as well. But I think when we started designing it, we really thought of the toy opportunity where we think it fits very well. But you can certainly try and push the limits of the technology to see where it actually works. So how does this all work? So I'll just talk very quickly about what's in Vuforia and how the Vuforia programming model looks like overall, and then I'll let David come and show you the Unity workflow. So when we talk about Vuforia, there are 3 main components. There's the client-side engine, and this is all the computer vision algorithms and tools and magic in there that sort of looks through the camera view, sets it up, and does all your detection and tracking. And that's something that's linked into your application. And we have multiple SDK variants to support different tool chains, and now for digital eyewear as well. We have the necessary tool support there. And then we have target management tools. Now these are Vuforia tools that allow a developer to tell Vuforia what objects, what car, what image that it has to look for, and then augment. Now for images, it's very easy. You simply take a picture, you upload a JPEG or a PNG file to our toolchain. So that's very well known. I think everyone has a camera. It's easy to create those. But for these kinds of objects, there's no simple 3D scanning tool. So we created a simple app. And I'll show you a demo of that app in a second. But basically, it lets you scan the object, gives you some real-time feedback, lets you do some quick testing as well to see if your scan was good or not. And then you can upload it to our target manager. And on the cloud side, there's a bunch of services. This is not really relevant for Object Reco, but we offer cloud recognition for databases over 100 images. You can put over 1 million of them over there in the cloud, and people have done many million actually. But so it's just something that if you're trying to use if you want more than 100 images, I think the Cloud Reco service is a good one. So if you think about the overall platform, if you've done like you guys are all I think you're all familiar with Vuforia, so this is not going to look any different. So I'll point out the one thing that's actually different is the object scanner. This is the new tool that's required for object recognition. And what it is like I said, it's an Android app. You just download it from our website. It lets you scan these 3D models, or 3D objects, and then that scan file, you would put it into our target manager, and then download a database that you then bundle with your application. Now, Vuforia itself, doesn't do any kind of rendering or content, business logic for content. We don't handle that. That's completely in app domain. It'll just tell you where the object is and where it is, and then whether you want to do an unlock, which is no augmentations, or you want to put augmentations specifically on top of the object. That's completely in application domain. Okay, so with that very quick introduction, let me just talk about how to use object recognition. So it's really simple. There are three steps. You just scan an object, you create a target database, and then you put this all together using Xcode, Eclipse, or Unity. And in this case, we're going to show you how to do it in Unity because it's really convenient and really simple. Let me show you how the object scanner works. So if we could switch to this, please. So this is an LG G3 device, and is that not working? Oh, it is working. Okay. So I already have a bunch of scans here, so I'll show you how to create a new scan. It's really simple. Let's do this. So there's a couple of things. So we provide a target. It's a standard known target. You just download it from our website and print it out. And there's two reasons why we do this. One is it gives you scale for the object, and then the other one is the orientation as well. Just to give you a reference for where to start the scan and how to put content on top of this. So there's this there's a little bit of grid here. The origin for the scan is here, right at the bottom left corner. Usually it's usually for the center of the object, but in this case it's at the bottom left. So I'll just show you. So what you'll do is you'll print this target out. You'll take your 3D object, you'll place it here in the center here, and then you'll see the coordinate bounds already out there. And then when you're ready to, can I see it? Okay. And when you're ready to start the scan, you simply press the record button there, right? And immediately you'll see that sort of dome-like thing appear. So this is meant to give you real-time feedback as you're doing the scan to show you how much coverage you have of the object. So why do you need this? You need this because in some cases you may not want you may want the object to be recognized only from certain directions or certain angles. So as you scan this, it'll tell you if it's covered it or not. You'll see it filling up all the holes. So I'm not going to do the whole scan, but okay, let me just save that. So then I can save this and and from within the app itself, I can test this scan out. So you'll see that it's showing me the coverage of how much I scanned and the portions of the object that I scan. So only that is actually recognizable. But because it's a pre-known object, once you recognize it, you know the full geometry and model for that object. So you can render content wherever you want. So I'll do a quick test here. Let's see if this works. So right away, you'll see that's the fast detection piece. It has to recognize immediately, and it puts a little cuboid out there, which I can then move around and then test my tracking performance out there. So recognize quickly, track robustly, and in multiple environments, right? Those are the key things. And you can do a lot of this testing from within the app when you're designing the product itself. So if you're working with a toy company, you'd engage with if it's a brand new toy and you have a lot of design flexibility, this is one of those tools that lets you iterate with the designer pretty much earlier in the development cycle. So once I do that, I actually would save this file and export it using the share button to my desktop, and then I would upload it from there to the target manager. So I think this is a logical point for me to switch to Dave's presentation here. And so he'll walk you through the Unity workflow. And what we're going to do out here is actually the card application in the video that you saw. That's exactly what he's going to try and build for you. And he's going to show you how to put some content in there and some tricks for how to polish it up. Because one of the things you do want is the 3D scan doesn't actually give you a CAD model. Okay, the model can only be used for recognition, but you will need a model of that car if you want to do some of that nice occlusion that you saw where the robot arm went around the car and it was correctly hidden and not like popping up like that. So you'll need that model, and you can get that model. Most toy companies will have that, or if not, you can build one from scratch. So let's just switch to David's. Okay, great.
Got it?
Yeah, it's on.
Hi, everybody. My name is David Beard. I'm the developer evangelist for Qualcomm Vuforia. So as Roy said, after he's generated the object data file, the scan that was created, he would upload it to the target manager online. One second. Is this fighting with my browser? Yes, it is. Here we go. So the target manager is at developer.vuforia.com, and it's a web tool for creating and managing targets online. So we have a specific kind of target that's known as an object target. Roy would upload the object data file, the OD file, and define the target type as a 3D object. He'd add the file in the browse window and then add it to a database. So once it's been added, the Vuforia car, which you can see in the center of the screen, he can download that database into a Unity project, right? So it's downloaded as a Unity package. He can just double-click on it, and it'll automatically import into the project. And then it's going to be added here. So if you look at this, if you're not familiar with Unity, let me just give you a quick orientation. Unity is really a game development environment primarily, but it uses an authoring workflow. It's really drag and drop. A lot of the configuration is done using this panel at the right that I'll show you in a second. If you look over to the right, that's where you're configuring things, you're enabling options, you're setting the different parameters of an object in the scene. So again, this is done as a drag and drop. It's a bit like working with Adobe or Flash or one of those sorts of tools. So I'll import the database into my project, and it's added in the streaming assets folder under QCar. Now, what I've also need to do in order to work with Vuforia in this context is to download the Vuforia Unity extension, and I've already done that here. But again, that's a Unity package. You import it into the project, and it automatically creates a project structure for you that you can use to then author Vuforia apps. So what that's adding here in the Qualcomm Augmented Reality folder is a set of prefabs. And in Unity, prefabs are really prepackaged components of features and functionality that are objects that you can use in the scene. And for Vuforia, we encapsulate all of our features as easy-to-use prefabs. If you look here in this panel, you'll see that we have the image targets, object targets, which is what we're using today, an AR camera, which is a special augmented reality camera that we designed for AR functionalities and capabilities. So what I'm going to do in order to create an object recognition scene is to bring the AR camera into the project. Oops, not into the console, into the hierarchy. And I need to add a license key to that. Let me just drag this.
So all Vuforia apps need a license key. You can get that from the license manager. We're not going to show you that workflow, but it's fairly straightforward.
Let me just add this here. And I'm also going to be using what's known as Vuforia Play Mode. Play Mode is a simulator for Vuforia that enables you to rapidly prototype Vuforia scenes from the Unity environment. So I have my webcam connected, and I just want to make sure that it's configured to use this. And we'll use that simulation as part of a workflow that I'm going to show you that will enable you to accurately register content on and around objects so that you can precisely anchor your digital content on the surface of the physical object when it's being augmented, and also to place objects in the scene around it so that as you're moving and looking at the physical object of the toy, that things behind it are being occluded properly, meaning that it looks correct for the depth perspective of the camera. So I've added the AR camera. I'm adding an object target, which is the target type that we're using. And you'll notice what this has brought into the scene is a bounding box. And if you remember, when Roy had scanned the target, there's a grid that he placed it on. There's a direct correspondence between these two. And you'll see when I add the object target database what the significance of that is. So I go to the AR camera, and here I'm going to select to load the database that I've imported to the project. And I want to activate it at runtime so that it's immediately accessible when the app starts up. I'm going to do something very similar for the object target itself. I select the database that I want to assign to this target, and you'll notice here that it's given you a snapshot from the scanning session. Now, if you remember, when Roy had scanned this, he had deliberately put it in a specific position on the grid within the scanning target so that he knew where that was going to be in reference to this bounding box. And what this enables us to do is to use the bounding box as a tool, as a reference that corresponds to this grid so that we know where we're going to be placing content, where on this target had the object been scanned, and it gives us a relative reference for where we want to put our digital content. And you'll see with this workflow how that works. Now we're going to be recreating at least a scene from the app that you had seen in the demo video. So I have some assets that are predefined for that. The first is the Vuforia car. So again, this is a CAD reference that we had developed for the car. It's not derived from the scan. It's really a reference model we had deliberately developed for this car property. I add that to the object target. The significance of this now is anything that's added to the target as a child of the target is going to be rendered as soon as the target appears, as soon as it's recognized. And also it'll enable it to follow that target in the field of view of the camera. It's known as tracking. I also want to add a directional light to this so that you can see what I'm looking at. So you can see the car here. Now what I'm going to do in order to ensure that the reference model has been accurately positioned is I'm going to go into play mode, and I'm going to give you a side-by-side view of both the scene view, which is our working view, and also the game view, which is our simulation view. I'm going to drag this over here. And watch what happens. Just give it a second. So you can see now the car has been rendered onto the surface of the object. And what this enables me to do is to test whether the registration is accurate by moving this model to see whether I'm correctly positioning it in the scene. So
I think this is a really big deal. I mean, trying to position that content accurately is an extremely hard problem. And doing this side by side like this is, it's one of the things we try to make easy for developers, is just to make it as easy as possible. I mean, for those of you who have built Vuforia apps, I mean, everything David has shown thus far is pretty much the same thing. It's just a different target type.
Okay, so that's pretty good. That looks like it's pretty tight. I'm going to take this back into the scene view. And now that we know that the reference model is pretty closely accurate, registered onto the surface of the car for the target itself, I'm going to use this model in the scene as a tool. And what I'm going to do is use it to position the other content. When you saw the sample that we were showing, there was a gun turret on the car. There's a robot arm that comes around and starts manipulating the car. So let me add these to the scene as well. Here's the turret. I'll zoom in on this a little bit. And now I can use the reference model, the CAD model, as a proxy, really, to position the gun turret. I don't have to go back and look at the car again in the play mode. And I'm going to bring in the robot arm. Now, one final effect, we're going to use a technique known as depth masking. I'm going to make this car disappear in the scene, but the physical model of the car will still be rendered in the virtual environment. What this enables us to do is apply advanced techniques like physics and such. What it'll do is establish a boundary, a virtual boundary for the car that you can use for gameplay, essentially. So you can bounce things off the car, you can impose colliders, you can make the car interactive. Let me show you how that's done. All I need to do is go in, I put in a depth mask shader, define that as a depth mask. You can see it's disappeared. And now when I go into play mode, pull this off here. You'll see the effect.
We have the latest PCs. It could be a Max.
I know. What's it doing? Demo gods, hold on 1 second. One more try.
We out of time?
Yeah, I think we're out of time.
Okay.
While you're doing that, we'll start taking questions maybe?
Okay.
Yeah.
Can you talk a little bit about your extended tracking?
We got a microphone here.
About extended tracking?
Yeah, can you talk a little bit about your extended tracking
Sure.
and the progress you guys made on that?
What specifically are you interested in?
I'm interested in tracking objects that are out of the scene view that
Yeah.
you can still keep tracking.
Yeah. So we've had extended tracking. I think it's one of our most widely used features. It's almost on by, we let developers enable it, but most people use it anyway. We've had it for, I think, a year now. It's used pretty widely for room-sized environments also in some cases. I don't think it was designed for those use cases, actually. There is some amount of drift out there. And you'll see in upcoming releases, we're constantly working to improve that under the hood, but it's not something that developers need to do anything explicitly about. I don't have an update specifically on extended tracking.
Before we take the next question, are Barry and Timothy in the room? We come start getting set up if you could,
Okay.
and then we'll take the next question.
Yep.
Are you guys planning to actually implement the redundant tracking?
The redundant tracking.
Yeah, it was like, it takes the same marker in a single, like
Got it. So you want duplicate, essentially your duplicate. We've got this feature request once in a while. Let's talk about it offline. I want to understand the use case better to enable that. Yeah.
And any plans for desktop support?
We're evaluating that. We realize it's a big ask. So
It is big.
yes. Okay. There's a question right at the back. Is gentleman with the tie? Yeah. Sorry.
You have a lot of mic, right?
You mentioned that you've done object tracking with appliances.
Yeah.
How would you use the same app to capture larger objects?
Yeah, it's the same app. There's a couple of ways you can do that. You can print the target a bigger size because it scales accordingly. Or some people I've known have taken large machinery and created 3D, just 3D print a smaller version of it, so they can put it on that target. It's not really designed for large objects, but those are two ways that I know that people have gotten around it. But there are limits to that.
Okay, thank you.
Yeah, right here, please.
Hi, I just wanted to mention that we use Vuforia for My name is Ron Friedman with Magic Cubes, and all the attendees have received these cubes, and we use the Vuforia with a reality app that brings the superpowers to life.
Oh, okay.
So everyone can demo it
There you go.
with the application.
Okay.
And it's in the conference bags.
One more question. Okay, good. Sorry.
My question is, if you cannot track large objects, do you have another solution for?
No, we don't. Not at the moment. You have a question? Oh, that's the same question. Okay, but you should really try, you should try both, which is try to print the target at a much larger size, so your object can actually fit on large amount of size. You can even print it on a plotter like 3 feet, 4 feet, or anything like that. Or you can 3D print a larger object to a smaller size, which I know people have done pretty successfully. Okay, do you need to start? I'm actually around, so feel free to stop by. Another question? Okay, please. You want to go?
Are you guys going to accept CAD-based tracking?
So the question was, can we accept CAD-based tracking? I think there are a couple of ways we can do it without it as well, which I understand that some people have been asking us about this lately, and there's some interest in on the enterprise side of things. But I'd like to really understand that use case better. I think we can solve it in other ways as well. Do you have a question? No? Okay. Okay, I'm around. Thank you so much for listening patiently and with the workflows as well. Feel free to stop by the booth. We're showing a bunch of AR, VR demos there. But happy to talk about anything Vuforia.